All right, well, we'll go ahead and get started. Everybody, welcome to the October 16th CNAB community meeting. The agenda is in the chat. Go ahead and add yourself as attending. Does anybody want to volunteer to take notes today?
I can take some notes.
Okay, thanks, Rabashi. Okay, so the agenda's fairly light today. We have a couple of topics. When can we move to cnab-io? Radu is going to talk about security and distribution, and Carolyn and I have a demo. So we'll start with the demos just because we'll get them out of the way and they're kind of fun first. Let me get the terminal window. So we're going to have two screen sharings. So first I'll go, and then Carolyn's going to go. It's going to be a cool integrated kind of demo. But first, I need a directory. One second. Okay, let me share. Sorry. Okay, is my screen coming through okay? Okay, so we're going to demo two things today. We've been working on Porter. It's going to be used for some internal things that really required the ability to deal with thick bundles. So we're going to show how we're handling thick bundles in Porter right now. And we also wanted to add the ability to handle remote claims and investigate what it looks like to use Go plugins. So we'll start with that because I think it's the more interesting of the two. So I'm going to create a new bundle, just like a Hello World bundle. So we'll just make a directory. So we'll do a Porter create in this directory. It makes a little skeleton. We'll modify this so we can publish it. My Docker Hub. If you're interested in watching me type. Okay, so I'll do a Porter publish on this. And that's going to do the invocation image build and push it up like we do for all of our stuff. And while that's running, first I'll come over here. Actually, I need to do it from this terminal. I'm going to run a Porter list command. So Porter list is how we view what bundles, like the claims that we have installed already. And you can see that this failed because I don't have an Azure storage connection string. So what we're actually going to do is do a demo where we show you storing claims in an Azure storage account. And that's going to be using a plugin. So that's going to happen in just again. But what we're doing inside of the Porter config that we have is specifying what we want to use as the backend storage. So we're using azure.blob. Conceivably, like these are plugins, so you could have like a lot of different plugins. And this is all Carolyn stuff, so she can talk to it more. But what we have is the ability to switch back and forth. So I can do like a local file system store. I could do something in Azure Blob Storage. We could write any number of other plugins to do that, and then just kind of flip them with configuration. So now this is published. I can install it. I can do Porter list here, and I have the environment variable. The environment variable set. And we can see there's something called cowsay that was installed already. So now I'll just install this thing. So I'll do a Porter actually. Tag. It's this. So do a Porter install from that tag. Should be pretty simple. Just do a hello world, so it'll pull this stuff down and run it. And now if I do a Porter list. I see now I have cowsay and hello. Cool. So now Carolyn's going to take over for a second and show you the other half of this.
Yep. All righty. So I have the plugin already installed, and I did a list, and so you can see 11 seconds ago, I can see cowsay, but I can also see the bundle that Jeremy just installed. Hello. So if I do a, sorry, I'm one-handed. I just hurt my arm the other day. So a Porter instances I can type really fast with one hand, right? Show. I can type in hello. Okay. So I can see everything about it that was installed and everything. So now I want to do a Porter upgrade. Oh, let's take off cap locks here. All right, and then we want to turn on hello. So I didn't have his demo, so it's pulling it down. Go Docker go. And then it's executing it. And so this was not a terribly exciting bundle. So it's printing out just that it upgraded world to world 2.0. And now if I do a Porter list, oh, sorry. We can see that it was upgraded. And if Jeremy switches over to his and then he did a list, he'd be able to see the same thing that was upgraded because we're sharing claim storage at this point. We're using the HashiCorp Go plugin model, not the standard Go plugin model that's honestly abandonware. So anyone could make a binary and with a couple lines of code, implement their own CRUD store. This is what's the interface that's in CNAB Go, and then be able to implement their own and then hook into this and be able to write their own implementation and then just switch out in the config which one they want to be able to use.
So there's a question in chat from Radu. Wait, am I muted?
I can hear you.
Okay, cool. There was a question in chat from Radu. Could the plugin be extended to use credentials, accounts, and allow modifying or not an instance?
Yeah, so for Porter, our hope is that in any extension point inside of Porter, so this could be credentials, this could be the builder where you decide to build a plugin, or sorry, build a bundle or executing a bundle, and it could be in other places too. We want to be able to use this for our plugin model. Modifying or not an instance. What do you mean by that, Radu?
To use the user account or the user that's logged into a specific storage backend, and say, for example, that user A does not have access to modify a specific claim. Or
it is tied to the user who's actually on the machine. So you had to have the right credentials in order to do this. It all kind of depends on how you'd want to set this up. Like we're kind of showing a couple things at once. One is the plugin model and kind of how it interacts with what we already have in CNAB Go, like the existing interfaces. And then two would be like some of this is customization that the tool can do, and like, okay, storing some things inside of say config file, but then some of it is how can we interact with the existing credential store. I don't think we'd want to do anything too far away from credentials. Like it still needs to be tied to the user that's executing the action. Yeah, I don't know if that answers your question. We plan on doing this for credentials and being able to say load your credentials from other places instead of just from say straight up an environment variable or a file, being able to get them from say Keyring or from Key Vault or things like that, and allowing other people to kind of make new sources of places for their credentials to come from. But it would still be tied to the user who's running the bundle action. And so one thing we were kind of open to kind of run past people or just get people thinking about is that would it be interesting to kind of have some of this plugin stuff, if that makes sense, live in CNAB Go, so that if other tools want to be able to have plugins as well, use the same model, kind of share some of the same interfaces. So if there was so for example, the HashiCorp plugin model has a common struct you end up making that represents what a claim store plugin would look like or a credential store plugin would look like. It has an interface and it has a very tiny little struct that goes along with it. Would it make sense to have that live in CNAB Go? Not all the implementation, customization, like where does the tool do all their stuff for it? but just what would it look like to load a common plugin for one of these things, claims, credentials, a driver, for example. So instead of having two different types of drivers, a command driver and one that's in tree, like the Docker driver, you could have a driver that was just a single instance of this type that just understood how to run a bundle. And then you wouldn't have to have like a first-class citizen that implemented an interface and it was able to have access to the IO writer and things like that. And then you would have to have a second-class citizen, which is our command driver, that has to use standard in, standard out, and isn't really able to do all the exact same things as easily. We could do this with plugins if we kind of had some of these common interfaces instead of cnab-go.
I think it would be interesting to look at the drivers that way, because I think Simon's on the call, Simon Davies from our side. He's been looking at how do we build like an ACR driver so that we can run these things in Azure Container, or sorry, in ACI, like how to run things in Azure Container instances. And I think he had to do that via the command driver. But if like we had this plugin model, he could just write like a first-class kind of plugin, and it would look and operate the same way that the other ones did if they were plugins as well.
Yeah, that's right. I use the command driver, but I also try and reuse as many of the types as possible in cnab-go, and it's a bit of a pain having to sort of force that. And I think the other advantage of this model, in my opinion, is the fact that you can choose to ship whatever as a tool. You can choose to ship whatever drivers you want in your tool, and folks can extend it. The interface is the same, so you get to choose whether, for example, with cnab-go, we could choose to ship Docker and Kubernetes driver and using this model, but still, if we wanted to plug in other ones like the ACI one, that could ship out of box, so to speak, but be exactly the same. It'd be a first-class citizen rather than a bit of a second-class citizen as it is right now.
Oh yeah, one thing I did mention was, because I didn't really explain like how the HashiCorp Go plugin model works, but plugins are all external binaries for the most part. If you wanted to ship something by default, it's implemented inside the binary. So say like Porter could have something implemented inside its own binary, but it still calls into its own binary, if that makes sense. So you can either ship something with yourself as a default, but it also has the ability to like call out to external binaries, but they're all treated the same way as far as like their capabilities, if that makes sense.
Are you saying that these plugins are something like shared libraries, are they?
I'm sorry, they're what?
Are they are the plugins main programs or shared libraries or what?
They're main programs.
Okay, all right. So there's some protocol for lashing them together, as it were.
Yeah, they use the one I picked goes net RPC. If you really need it, you could also use gRPC. I didn't really see the need for it for what we were doing because claims are super simple.
Okay.
Yeah, the HashiCorp library supports gRPC for other languages, like Ryder just mentioned.
I had a question about the claim storage side. Maybe that's not the main point of the demo, but it's interesting. We are looking at using cnab on Kubernetes. So if you deploy a bundle to a particular cluster, you'd want the claim storing in that cluster. And then if you deploy the same bundle to a different cluster, you'd want the claim storing there. So how does the plugin decide where to put the claim? Is it just a fixed address, fixed instance?
So this is like a really early proof of concept. At the moment, the plugin that I wrote is looking for default connection string. So Azure by default understands an environment variable called Azure Storage Connection String. And so it's looking for that and it uses it. Porter has a configuration file though, and the plugin can look for that configuration file and fall back to it. So there's going to be layers of configuration, and it's going to have like a preference essentially. So it's going to look for the most explicit, which may be something that was passed into it or in the config file. And then if it doesn't have anything that was preferred, it's going to eventually just fall back to that ambient environment variable if it can find it. And if it can't, then there's nothing it can do about it. So
it's kind of orthogonal to the driver, and its understanding where the cluster is, that kind of thing.
Yeah, so I mean, for Kubernetes, it may just be like, by default, I'm gonna look in a certain secret or something like that, unless you give it something more specific. But it's gonna have to be configured somewhere.
Yeah.
A Kubernetes claim storage plugin could just use your kubeconfig that you're using. So like it's going to use a kubeconfig for the driver, and that driver is going to point to a certain cluster when it runs. But the claim storage plugin could use the same kubeconfig file and say like, store all the claims for this kubeconfig in that cluster. I think it really comes down to how those plugins get implemented and what decisions you want to make about where the storage is going to lie, what configuration.
Yeah, and that's what I meant by some things would be in cnab-go, the interface for the plugin, but for the specific tool or the implementation, like where do you find your config, that may be incredibly specific to the tool. So that may be outside of cnab-go.
But they'll still get to operate in the same way. Like it'll still be like a first-class citizen because it's using the same interface.
Okay, one last question, since nobody else is interrupting me. How about concurrency? If you've got two operators operating on the same bundle, are there any kind of ACID guarantees on the storage?
That was the other piece of this. So I was going to say that for selecting what type of backing storage types can be allowed, they have to support atomic locks. So that's why I picked Azure Blob Storage, because I can acquire a lease on a container and a blob and prevent people from colliding on a file. I think that's critical, otherwise you can't do this. So some storage mechanisms may not be workable at all as backends.
So with the concurrent access, the loser would get an error, essentially.
I'm sorry?
With concurrent access, the loser would get an error, essentially.
I don't even think you can have like optimistic locking, because at that point you could have kicked off two bundles at the same time that had real repercussions to them running. I think you need to pessimistically lock on a claim ahead of time.
Yeah, I don't disagree. I'm just trying to understand what happens.
I'm kind of thinking we may need to make spec changes to say that I'm performing something on a claim and lock it so that somebody else can't. Say like I'm doing an upgrade, I need to lock it so that somebody else can't perform a concurrent upgrade at the same time. I don't think the spec supports that right now because we updated at the end. Okay. I need to be able to lock a claim at the beginning and state that I'm performing an action, and somebody else who wants to perform an action on that claim that wants to modify resources needs to wait.
Oh, right. So the wait rather than failing.
Something, yeah. We need to hammer that out in the spec. But I don't think concurrency right now, the way the spec stands, is supported at all.
Okay, yeah, that's fine.
Yeah, because of the fact that we update at the end of the action, and there doesn't seem to be a way that we can mark on the claim that an action is in progress. This is an issue that Butcher and I started talking about, I don't know, right before we marked 1.0. This is something that we needed to start considering, you know, basically in saying that an action has been initiated and that other people who want to perform a mutating action need to hold until we're done.
Okay, thank you.
Yeah.
All right, I'll do the last part of our demo and then we can move on. So the next thing is we added thick bundle support. So we've added a command called porter archive, and it looks something like this. Actually, you can specify file, local bundle, some other JSON file, or a tag. So I'll do that. And again, like our Porter YAML is this thing, so let's just archive that. So we'll do a porter archive tag, and we'll call it hello meeting.tgz.
You didn't get the J on your Jeremy there.
Oh, I can't type or copy and paste. So this is all pretty silent, and we don't have a lot of like logging going on, but what's happening is it's pulling all the stuff down, and then using the code that was in Duffel to do export. We're leveraging that because we moved it into cnab-go. So now we get a tar file here. If I do a tar, hello, yeah, so we have the layouts and the bundled JSON and stuff. And then conversely, the use case we wanted to expose for dealing with thick bundles was basically rehydrating them into some other repository. Because like in most cases, you're probably going to need all of the images into a repository. So we're using the image relocation library to do that. Thanks, Glenn. So we use our normal publish command. We specify, so we can look at help in that. So we specify an archive file. So we can do -a, hello meeting, tgz, and then we give it a new tag. So I'll publish it to Deus Labs because it was in my repository before. Hello meeting v0.1.1. And basically the inverse is going to happen. We're going to use the image relocation library to copy those layouts up to that new repository. We're currently mutating the bundle JSON before we store it with cnab-to-oci. That'll run for a second, and then I can run the same install. I could do a porter install off of that new repository, and the same kind of operations would happen like any other published bundle. Yeah, so it's starting. There's the cnab-to-oci stuff happening.
And so this isn't doing a relocate, right? This is a copy down and.
Yeah, so it's using the relocate library to copy the layout, the OCI layout, into a registry, but it's not preserving the bundled JSON in terms of like the image names and digests. We're currently mutating that. So there, it looks like any other one. So those are our big changes. Any questions on that one? Cool. So I think that thick bundle demo kind of sets us up for the next one agenda item, which is Radu telling us about the security spec.
Yeah. So over the past week, Dushank and I have been working on updating the 300 sections of the CNAB spec, which is the security part. And the TLDR here is that we decided to significantly simplify the proposed model. So if you read the 301 section in the last couple of weeks, you might have seen a large image, large diagram with lots and lots of keys and relationships between keys. Essentially, we have decided to bring down the scope of what we want to define in the specification to just the basic keys and definitions of TUF, and essentially to have only define only the keys from TUF, which are the root timestamp, snapshot, and targets, and led to the implementation to essentially decide how to use those and how to do do delegations or not. So essentially, right now we're working on cleaning up the remaining documents. I'm working on the verification workflow, and the thing that I wanted to raise with everyone here is whether or not we could have the same verification workflow for thick and thin bundles. So essentially, just to take a step back, the signature of an artifact is the content digest of it, which is signed with some keys and pushed to a TUF server, right? And regardless of whether it's a thick or a thin bundle, if it's in an accepted bundle format, which is a canonical JSON for thin bundle and the proposed archive format for thick bundles, the signature is in fact the content digest regardless. So we could simplify that even further and just state that the verification workflow deals with the content digest of the bundle and not differentiate between thin and thick bundles. I think we could leave this to implementations if they want to further look into other validations for thick or for thin bundles. But right now, the current implementation that we have for Sign works with both thin and thick bundles. And if it's a thin bundle, it's going to pull it from an OCI registry using cnab-to-oci and do all the things and validate the signature. And if it's a thick bundle, it works with a local file. So it takes a local file that you have in your file system that you can pull from anywhere basically and compute its content digest and then verify with the signature that's in TUF. I think, and we're going with Shank over this, we think this works and we don't invalidate any guarantees by doing this. So if you have thoughts on this, we'd love to discuss it. Ralph, you're muted.
I suppose if the thick bundle included non-standard pieces, sorry, my microphone is probably not working well. It would be strange to hear me. If thick bundle is included non-standard pieces, now then that wouldn't be covered by the signature of thin bundle, would it?
So the thing to note here is that if you have a thin bundle and a thick bundle, you have this. If you do a duffel export of a thin bundle, sign the thin bundle and then sign the thick bundle, you get different digests, right? Because in a thin bundle, you take the content digest of the canonical JSON, and in the thick bundle, you get the content digest of the archive. So they're going to be different, right?
Okay,
so you don't have the same object anyway. The next question is whether or not we should take the content digest of the bundle JSON. No, I don't think it makes sense to digest the bundle JSON for thick bundles because it's not what you receive. When you receive a thick bundle, you receive the entire archive, and I think that's what you want to guarantee on. But I'm open to discussion here, obviously. And then, go ahead, sorry.
Just wonder about a use case where you push a bundle to a registry and it's all good, it's a thin bundle, and then someone carries it across to another data center, for instance, by exporting it to a thick bundle and then importing the thick bundle or relocating the thick bundle to their private registry. Would the signature be preserved?
If the content digests of the referenced images in the bundle are preserved, which right now with both cnab-to-oci and image relocation are preserved, then yes, the signature of the thin bundle is preserved, regardless of what happens with what form it is in.
Okay, so the signature of so the signature is preserved, is carried into the thick bundle. The signature of the thin bundle is included in the thick bundle. Is that correct?
It depends on what the end user the final user is trying to validate. If they're trying to validate the thin bundle signature,
yeah,
then if initially it was pushed to an OCI registry and the signature was pushed as well, then yes, the thin bundle signature is preserved. If initially the thick bundle signature was pushed and the end user is going to try to validate the thick bundle signature, then yes, it's going to be preserved as well. If the first user is pushing a thin bundle signature and the end user is trying to use a thick bundle and validate the thick bundle signature, then that's not preserved because they're different contents. And I'm thinking about whether or not to include the thin bundle signature when you push a thick bundle signature just as a custom target. Would that be useful? Would that make sense in any scenario?
Maybe, I don't know.
So Radu, can you restate that last question?
So if you're pushing a thick bundle signature somewhere, you're already doing the work of archiving the bundle and taking the content digest of it. You also have access to bundle JSON, to the thin bundle when you do an export of the bundle. So you would be able to also push the signature or at least the content digest of the thin bundle in the same trusted collection as the thick bundle signature. So an end user that will have access to the thick bundle could also validate the content digest of the thin bundle as well. I'm not talking, I wouldn't be open to doing this the other way around when you do a thin bundle signature, because it requires additional work to tar up the thing, and you might not have access to doing that. Whereas when you push a thin bundle signature, all you need is an OCI registry not to export everything up, which is a costly operation. So I'm interested in whether use cases for thick bundles would benefit from the thin bundle content digest or not.
So
it is included. If you sign the thick bundle, then you automatically get a guarantee that if you take the thin bundle out of the thick, it is the same content because it is included in the signature. But I'm interested in whether it would be useful for runtimes to just have access directly and validate also the thin bundle signature.
Well, so there's a split scenario here, and the question is whether, I think it would probably be useful in a general sense. First of all, the scenarios, the user story for that usefulness is pretty niche. That scenario, if I understand what's being said, is the case where you have moved a thick bundle somewhere, and the thick bundle has access to the thin bundle signature information. The only case where that would matter is if you wanted to recreate a thin bundle out of it and then test the signature.
Well, the scenario that Glenn described did just that. It rehydrated an internal registry based on a thick bundle. So it might be useful. I think we could at least not block it by the security spec.
I don't think it should be blocked. That's for sure. Yeah. I mean, we could take that first step and just say, let us not prohibit that, right? I do think we should write in a note that what this means is it gives extra abilities when we transfer the bundle type from one to another. But we merely say that it provides that possibility if it's included. That's all we need to say.
Okay, that makes sense. And then the final question on this, which is probably the largest one, is right now the sign implementation of the security spec allows you to check the signature of a thick bundle more or less the same way you do for thin bundles. So you take the content digest of the archives of the exported bundle and push it to a tough server, right? The question is, when you do the validation part, you need access to that tough server. You need access to the original trust collection. So the question is, in most scenarios that people have in mind, for thick bundles, would they have access to that original tough server in the environments where they want to validate it, or is that environment already locked down and they don't have access to it? And what options would you see for doing this?
I have many thoughts, Radu, as you know, but I'm going to not pollute this with thoughts first. I'm going to solicit from everybody else.
I suppose we got in mind the air gap scenario. So in that case, you'd have the thick bundle inside the air gap, and it wouldn't have access to the tough server. So you probably want some sort of thick representation of the tough contents porting across as well.
Yeah, that's what I was thinking. So essentially, you need access to all the tough keys and all the tough snapshot, root files, metadata files, in order to do the complete validation of the signature. So not only the content digest of it for a full validation. I'm interested in whether the validation itself could be done in a DMZ zone and then moved in a completely shut off environment or not.
This is where I was going. There are actually 3 sort of scenarios, and one is, or 4 technically, but really, there's the completely offline scenario where you cannot acquire the metadata necessary to verify, in which case the verification happens before the physical transfer and with some human that is trusted. And then from that point on, it's a human out of band trust process, right? That's the sort of extreme case. But there's a middle case, which you might call DMZ, where the offline, what we're calling the disconnected environment, is actually connected but controlled, and there can be whitelisted certain outbound calls, right? You could call that a DMZ scenario. You could also call it like a Verizon cell tower scenario, whereby inbound calls are dramatically restricted, if not forbidden, but outbound calls from the edge are for certain kinds of updating, certain kinds of validation are permitted along controlled routes. That is basically a network out of band trust. That scenario enables this ability for probably, Glenn, anybody else, take a swag. But my guess is that enables this edge capability for probably 90% of edge cases, and the only ones left are truly disconnected cases where the risk tolerance in those environments is so low that they're likely to have human processes anyway.
Yeah, I agree with that. I'd just be interested in what's the theory about doing an offline verification? Is it possible to port the tough metadata across in such a way that it makes sense in the disconnected world? Or do you always need access to the tough server to validate the route?
So right now, with the current at least notary implementation, you cannot truly move an entire trust collection from one server to another. I think there's effort, or at least tentative effort, for a notary v2, which would work with the OCI artifacts project, and this is high up the list on the requirement. So we could potentially benefit from that. That being said, you would still need the entire all of the keys and all of the files to validate that. So you would have to move the entire trust collection, not just a single file or some part of the collection.
From my perspective, once you get into an environment requirement like that, then your real dependency is not a CNAB dependency. It's actually a trust validation store dependency. That is, let's imagine, say, a submarine, or maybe let's just keep it out of the military because the military is no fun for anybody. Let's call it an underwater bioresearch lab. And they get deliveries of things once a week in a space station. Go, Jeremy. No, wait. Got to get a little more reliable first. So in this environment, let's say they get a resupply every week. One of those resupplies, maybe once a month, they get a metadata copy. I'm just trying to use this as an example for understanding how I would operationalize this if it really mattered to me. And if they get a metadata copy once a month, then they essentially get a sync moment with metadata. Any new bundle would be unverifiable. But in that environment, you might believe that that's the case. You don't wish to do dynamic updates that fast because your risk premium, your risk tolerance is extremely low. Again, right? In that environment, you don't necessarily want to be randomly letting people updates. And so my suspicion is that in this case, this is the way I'm thinking about it. And like, if we come up with a use case that doesn't fit this model, I'd love to hear it. But I think that in those extreme disconnected cases, the real problem is making sure that you have an operational model for confidence with your updates, which involves the metadata transfer and not the bundle, which I want to point out, you could still do the signature of the bundle with a much simpler operation.
And just to tie in the last conversation is you would still need a tough server in your disconnected environment where you would move your things into. That being said, for completely disconnected environments where you simply cannot make an outbound call to a trust collection to a tough server, you could potentially get and validate the signature in a connected zone. And write an in total link that validates the fact that a specific operator, human or computer, validated that signature. This is the content digest that was validated with the top server, and pass it inside a metadata, in total metadata, and pass it to the completely offline environment, which would perform the verification of the content digest. So you would still do both the top verification in a connected environment, and then perform an additional one in a completely disconnected environment, which we just would compare the digest that was written in the metadata, in the total metadata, with the local one. So it would not be directly to TOF, a call directly to TOF, but you would have an additional verification that someone performed the TOF verification, and this is the digest, and you could verify it for yourself in the disconnected scenario.
I mean, in my view, this is a hard problem to solve because being truly secure using signatures requires access to stuff which we normally think of as being connected, right? Otherwise, I mean, literally what we're doing here is there's sort of like a one-time pad encryption process for these signatures, right? We have to have agreed on precisely the same thing in two different places before you can have confidence that it is validated. Cheers, man. That's actually just a hard problem. And computers make it slightly easier in the outbound only or controlled outbound case. But I actually think the priority here is to sort of identify these cases and call them out as not solved in the spec. That is, we need to call them the scenarios out and say, here is the process that must occur in some way for this particular scenario. And we may even get to the point eventually where we say this implementation will solve this problem if you wish to use it, or you can implement your own. But I think the clarity here about which boundary gets you what level of signature and security confidence is the high order bit for the spec. At least that's the way I see it. In particular, because even in Notary, which we'd love to use, you know, there are limitations. The simple fact that you have to have a trust server on both sides, even if the server did everything we wanted it to do, means that you're still doing some out-of-bound thing that the tooling may or may not know about. And so there's still going to be some, in those critical scenarios, there's still going to be sort of steps that we have to call out as needing to be done. At least I think that's productive rather than restrictive.
Yeah, and for this meeting, I just wanted to lay out all the use cases and the requirements for each of them and how they are currently implemented and what is not. So hopefully that makes it not particularly unclear. Is there anything else on the security discussion we want to touch on?
I think we're good there. Let's move on to the distribution spec.
Okay.
Yeah.
Distribution topic.
One quick note. Probably to add it. No. I'm not going to bring it up here, but I'm going to ask to be added, have it added to the next security discussion agenda. So it's really for notes, which is the question of credentials and disposition inside the Docker image, whether we wish to say anything about that, depending on which part of the process might pick up and use a credential as opposed to what else happens to be passed, because there's a lot of stuff that gets passed. So there's probably worthwhile discussion there to see whether there's any sort of light that we can bring in that area.
Oh, and the final thing I forgot about it is we should probably schedule a sync with Steve Lasker and Justin Cormack, who are sort of discussing about the OCI artifacts project and the security part of it. And I really think that we should sync up on their work there and at least compare notes on that. Sylvan, do you want to talk about the work in progress in cnab-to-oci?
Yeah, sure. So yeah, we just opened a PR to be able to push your local images, like the invocation image you just built, or any service images you built locally. So we're introducing a dependency on the Docker client for that, so it can talk to a daemon to push your image to the registry. One limitation there is that Docker daemon is only able to push on tag. So we use the same trick as multi-architecture images, and we push all those images on the same tag, which is the final bundle tag. So yeah, right now it's just a draft PR, so you may take a look at it and please comment.
Okay, so the last thing on the agenda is when can we move to cnab.io? And
there was one tiny point there. Yeah, sorry. We should sync up on the OCI spec discussion. There was an action item from a couple of weeks ago that we were supposed to try out the OCI index versions, how to increment it either to have a 1.1, which the spec clearly doesn't support, or increment to a 2. So at least Sylvan, Chris, and other people interested in this discussion, do you want to schedule something this week or early next week to just try out incrementing the OCI spec on it?
Sure, we can do that. Let's take the organization of that onto the CNAB channel.
If anyone wants to join that meeting there, feel free to. Sorry, Jeremy.
Yeah, sorry. No, that's a good point to add. So last thing on the agenda was when can we move to the new organization that we set up? So I have an email chain going with Seth Newberry from JDF to see if they can provide us a CLA bot. I think that's kind of necessary before we move any of the code stuff over. And he's also investigating whether we need a CLA or if we can just do DCO. He is traveling this week. I pinged him again today and got an out of office response, but hopefully next week we'll have an answer and we can start making plans. I think Radu volunteered to move Siny in there first as like a test to see what breaks and what things we need to set up and what things we don't have. So that's probably be our plan. Maybe move the community repo over as well. If anybody has any thoughts on that, we can discuss it in the CNAB Slack. Cool. Any other topics we want to discuss in the last couple minutes? All right. Well, everybody have a great afternoon or morning, wherever your time zone is, evening, and we'll see you next time.
Thanks,
Cheers,
Jeremy.
everybody.
See you.
Cheers.